So here's a picture of the cranial nerves, and we study them as kind of a lecture together because cranial nerves are they're paired nerves that exit the cranial base. That's why they're called cranial nerves. Exit is a key word because you have to know how they exit. And when I lectured on the skull, I lectured on all of the foramen that basically through which those cranial nerves exit. And well, as I go through the cranial nerves, I'll remind you what they are, and you got to know it. What we see from the picture is, one thing you see is that these cranial nerves, most of them kind of emerge off the brainstem. It's a fun little figure that's in every anatomy book. Another thing you notice, if I zoom in on one, the print's real small. You know that the cranial nerves are numbered, like 1 to 12, using the Roman numerals. And they're numbered according to the order in which they emerge off the brainstem. Okay? So I guess I can tag onto this. They're numbered accordingly. 1 to 12 using Roman numerals. So you have to know that. And they also have names. So they have to know names and numbers. And yes, you have to know both, of course. They're numbered, they're named, and of course they have function, right? And in cranial nerves, when we kind of talk about the different functions of nerves, we've been talking about how cranial nerves, or nerves in general, they can have a sensory function, or basically a motor function, right? And by now, you know what that means, okay? When I would use these words in terms of a nervous system lecture. You know, these nerves can be sensory, they can be motor, or they can be both, they can be mixed. If that term is ever used, it means it has some sensory function and some motor function. And of course, you have to know the function too. And you know, there's different kinds of sensory, there's different kinds of motor, right? We talked about that. There's somatic and visceral motor. And for sensory, there's somatic and visceral too. Now even add another one, what's called the special senses. Ones we haven't talked about yet. Somatic sensory is basically skin. Information from skin, like touch, feel, vibration, pressure. But what about seeing? What about hearing? What about gustation? What about smelling? Well, those are special senses, and as I go through the 12 cranial nerves, I'll point that out. This next figure here, I show you the picture from the previous slide, how they emerge off the brainstem, basically, the bottom of the brain. The other way you could study cranial nerves is to study them where they exit. Okay? Oh, you know, let me get a skull and demo. know, just to demo what students should be able to do, you should at least be able to name them and say where they exit. And as a good practice activity for if you go to the open lab or if you have lab time in class, is just to kind of take a pointer and just kind of go through it with you and a buddy, anybody in your class, and just name them and just name where they exit. Cranial nerve 1, olfactory nerve exits the olfactory foramina of the cribriform plate. Cranial nerve 2, optic, exits the optic canal. Cranial nerve 3, oculomotor, exits the superior orbital fissure. That's right there. Cranial nerve 4, trochlear nerve, exits right there. Superior orbital fissure. Cranial nerve 5, that has 3 branches. Branch 1, ophthalmic, exits superior orbital fissure. Branch 2, maxillary, exits the foramen rotundum. Branch 3, mandibular, exits foraminal valley. I'm on number 6, that's cranial nerve 6, abducens, that also exits superior orbital fissure. 7 is facial, that exits internal acoustic meatus, as well as 8, vestibular cochlear, exits internal acoustic meatus. Cranial nerve 9, glossopharyngeal, exits jugular foramen. 10, vagus, exits jugular foramen. 11, spinal accessory nerve, exits jugular foramen. And 12, hypoglossal nerve, exits hypoglossal canal. That's right there. See, no, I didn't do it to show off. That's what you're going to be able to do. Okay, what I just did, you're going to be able to do it. I don't know how long it's going to take you, but that's the kind of mastery you need. You can do it that fast, you know it. Okay, and I remember when I was a student, you know, we did exercises in class, and they made us know it in like a half an hour. You know, we did different drills and stuff. But there's different ways that you can study the cranial nerves. I don't do that kind of thing unless, if I expect you to know it, you got to know I can do it, right?
Right.
So I just did it. Now I expect you to do it. All right, so any questions on the general? Okay, I got some memorization to do. But you also have to know the functions. I want to emphasize that. Okay. Let's move on by just kind of going through them. Cranial nerve 1, olfactory nerve. Olfaction is smell, so this nerve smells. That's its function, that's easy. And smell is a special sense. Okay? I've talked about smell beforehand. Basically, well, smelling is a special sense, and there's no motor function for this nerve, so this nerve is purely sensory. Smell is a sense. You have to know how it exits, and I have a couple of pictures here. This is the ethmoid bone, that's Christogalli. Here's the olfactory bulb. Okay, so the olfactory nerve, be able to distinguish olfactory bulb. There's all these little olfactory fibers, and they're exiting the olfactory foramen of the cribriform plate. Okay, after they exit, those little nerve fibers, to pick up the odor molecules, they embed in what's called the olfactory epithelium. Here's what you can study right there, the olfactory epithelium in terms of the function. How do they smell? Well, you have to have little nerve endings in your nose. Study the olfactory epithelium where those nerve fibers terminate. Study olfactory epithelium. I would say just what is an epithelium? Well, it's basically these supporting cells, these epithelial cells. Let's call them supporting cells. And they surround the olfactory sensory neurons. So that's what the olfactory epithelium is. It's basically supporting cells surrounding olfactory sensory neurons. Now this epithelium is a mucous membrane. There's glands that secrete a mucus. Right there, that's important. The mucus will catch the odor molecules. All right, that mucus cells. Provide mucus, do I have to rewrite that? Well, the mucus has a sticky function. Mucus will bind odor molecules. Odor are molecules, okay? I know you can't see them. So you sniff, the odor molecules get trapped and trigger the olfactory cilia, which are embedded in the mucus layer. That's what I'm writing. Now, the olfactory gland that secretes the mucus is up here. But basically, if this is a sensory function, let me ask you this. Is information going up or down? If it's sensory, it's going up to the olfactory bulb and going back to the cerebrum. It's a sensory function. It goes to a certain part of your cerebrum and you pick up that whiff. And you don't have to know all those other cells that are listed there. Basically that's what I want you to know here. The information are all hooked up and it goes back to the brain. I'm going to move on. Cranial nerve 2, optic nerve. So here's a picture of the sphenoid bone in and out of the skull. Sphenoid. Because cranial nerve 2 exits optic canal of that bone. Okay, now this nerve it sees, it's for the sense of vision. Vision is a sense. It's not a motor function, it's a sense. You see. Vision is a sense. This nerve is purely sensory. There's no motor function in cranial nerve 2. Here's another look at it from the side so you can see it going into the eyeball. It exits cranial nerve 2. Optic canal. So they kind of name the hole in sphenoid kind of like, based on the function of the nerve. You can see optic. I do want you to be able to distinguish optic nerve from optic chiasm from optic tract. Okay. There is a difference in the vision here. So know that you have two optic nerves because you have two eyeballs, right? Correct? A right and a left optic nerve. And, I talked about the visual fields. The visual fields being, if you gaze at a dot, okay, and divide the room in half, you see things on the left and on the right. Those are the visual fields. If you close one eye, I mean, I can see things in the right visual field with my left eye. So what I'm trying to say is, each optic nerve carries information from both visual fields. I'll just say right and left visual fields. I'm going to jump ahead to like my last slide and get a better sense of what I mean. I'll come back to this. And the students don't like it when I jump around, but here we go, jumping to the end. Holy smoke, okay. Well, anyways, left and right visual fields, blue and yellow respectively, to color coded. And each optic nerve is carrying information from both visual fields. Notice that the optic chiasm, that's where the optic nerves cross, as well as the information. Info crosses. I'll just say optic nerves cross. Same difference, right? After they cross, call them optic tracts. What we see is the information is different. The optic nerves carry information from both fields of vision, okay, left and right visual fields. But, for example, the left optic tract only carries information for the right visual field and carries it to the left side of the brain and vice versa, okay? So left optic tract, right optic tract. We're carrying information from the opposite visual field. So left optic tract is carrying information only from the right visual field. The right optic tract is only carrying information from left visual field. Okay, so that's the difference there between nerve, chiasm, and tract. So I'm going to go back to cranial nerve 2. I'm done with that for now. I have a whole lecture on vision today. I'm going to do the eye after break. And, but I still want to talk about the eye right now in terms of not just vision, but moving your eyeball. So those are the eyeball muscles, the extraocular muscles. And these cranial nerves will serve most of that function, or pretty much all of that function. 3, 4. I'm going to skip 5 for now and go back to it and do 6. Okay. Now the oculomotor nerve, let me show you this picture. Along with 4 and 6 will innervate what are called the extraocular muscles. Okay, so I'm going to do this one with that's 3, 4, 6. Again, you learn your Roman numerals. 4. And 6 is abducens. These all innervate what are called extraocular eye muscles. They basically move your eyeball in all directions. Extraocular eye muscles, let's name them. I just have them numbered here, but I mean, they don't go by numbers, they go by just their names. Number one is a muscle called the superior rectus muscle on top of your eyeball. So don't worry about attachments. You can see they're attaching to the eyeball, right, in different locations. And based on where they attach, again, like any other muscle, how does it move the eyeball? If you attach on the top and that muscle pulls on the eyeball from the top, how's it going to move your eyeball? Basically look up. Can you see that? I think so. That's not hard to understand. Superior rectus, that's number one. Number two, medial rectus. So if you pull from the inside, look at this eyeball. This eyeball will look that way, right? For that muscle, for this eye. Okay. Pulls, because some people, you can like look at your finger and both eyeballs go in, you get cross-eyed. But that's medial rectus, pulls the eyeball inward. Number three, inferior rectus. That'll help you look down. Number four is a muscle called the inferior oblique. So it's not inserted straight on. It goes kind of obliquely and inserts. Number four. Inferior oblique. Now that muscle, when it pulls from the bottom on the outside like that, it's going to pull your eyeball. If you imagine, if I pull this way, it's going to pull your eyeball to look up and lateral. So this helps you look up and laterally. Now these first four muscles are all innervated by oculomotor nerve. Cranial nerve 3. So know the innervation. 3, 3, 3, 3. This is voluntary muscle. Is that a somatic motor or a visceral motor function when you move your eyeballs? Somatic motor. Skeletal muscle, somatic motor. All right, so that's somatic motor function. Boom, 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 boom. What about the other two? Different nerves. Cranial nerve 5, trochlear nerve. Oh, I'm sorry. That's the name of the nerve. The muscle is superior oblique. Oh, I was thinking ahead. Getting ahead of myself, my thinking process. Anyways, you can't see it very well here, right? The muscle is right there. See how the tendon goes through a trochlea? And then it's going to insert on the eyeball over here. Now I know the picture I am using, you're not getting the clearest view of it. And I also know that Lab Practical 3 is based on pictures, right? Are you guys just hearing that for the first time? You guys knew that? Tell me this, did you see the pictures I posted?
Yes. I haven't seen them yet.
Okay. If that's a no, you better get on it, right? So it also helps, even though you're only responsible for the pictures, if you wanted to stay in lab and actually study the models we have, that helps too. For those of you who are more visual learners, the two-dimensional picture is not helping me. I need something three-dimensional. So there is going to be some lab time if you want to study those in the lab. That muscle helps you look this eyeball down and laterally. It's pulling from the top, so you look down and lateral. Okay. and it's innervated by the trochlear nerve, cranial nerve 4. The nerve is named because this muscle goes through a trochlea, a little pulley right there. Okay, the muscle is superior oblique, the nerve is trochlear nerve. They call inferior oblique, that muscle, your angel eyes. Because when you accuse, like, you know, my 6-year-old of, did you do that? And he goes, no, I didn't do it. You look up and lateral, right? Angel eyes, right? I didn't do it. I'm innocent. Or my 12-year-old rolls her eyes at me, looks up and lateral. Or when you roll your eyes when I say something that annoys you, whatever. But angel eyes, they call this one your cheater muscle. Because you look down and lateral, like when you cheat. And so it always helps me remember the reaction. But we don't want you to do any of that, lie or cheat. This one here is called, the muscle is lateral rectus. Because I don't know if you can tell, it's all zoomed in. The nose is here, makes this medial, makes this lateral. The muscle is lateral rectus. The nerve is cranial nerve 6, abducens. That's the nerve that innervates it. Because this nerve helps you move your eyeball laterally. Like it's abducting it abducts the eye, right? You pull the eye, you know, away from the midline. Abducts the eye, the name of the nerve, abducens. Okay. It's pretty straightforward. Now there's another muscle here that doesn't insert on the eyeball, it inserts on your upper eyelid. And the name of the muscle I want you to know is called levator palpebrae superioris, palpebrae being your eyelid. So know that muscle. Levator palpebrae superioris. So I have to use a different figure to teach that muscle because on the previous figure, well, there was no eyelid, but they do show it here cut away, right? All the red arrows pointing to it. So don't confuse that one with the superior rectus. If you see a muscle inserting onto the eyeball itself, not the eyelid, the eyeball muscle, superior rectus, the eyelid muscle, levator palpebrae superioris, innervated by cranial nerve 3. So that nerve does a lot, oculomotor. It also, well, palpebrae means eyelid. Do you think levator implies, you know, lift the eyelid or lower it? Lift. Okay, you know, open your eyes basically. Elevate eyelid. That's the action of that muscle. Well, here's a slide that kind of summarizes the actions of the muscle. You can kind of look at that. I mean, like I said, here's the cheater muscle. For this eye, down and lateral is that muscle. Okay, it's going to be different for the other muscle. The only time you don't use in muscles is if your gaze is forward. All right, the ciliary muscle is smooth muscle. So these muscles here are skeletal muscle, it's voluntary muscle, but smooth muscle is not a somatic motor function, it's visceral motor function, right? Because oculomotor nerve also does, it helps focus your lens and it helps constrict the iris on a bright sunshiny day. Sun shining now, but is it supposed to rain later?
No, I just think
I
it's
thought it was
getting
supposed to
cloudy.
rain. Okay. I think it was going to rain. Well, anyways, let's talk about the visceral motor function of cranial nerve 3. Let me show you a picture here. Lens focusing. Also called lens accommodation. accommodation for what? For close vision, seeing things right in front of your face, like reading a book. So lens focusing, lens accommodation is what this is called. The smooth muscle, the ciliary muscle, innervated by cranial nerve 3, is circular. Okay? Circular muscle, and there's all these radiating ciliary zonule, these suspensory ligaments that attach to the lens, the structure that actually bends light rays for you to see things, where your photoreceptors are in the back of your eyeball and the retina. Okay, so anyways, that's the lens. All right, so ciliary muscle. That is the smooth muscle that's innervated by cranial nerve 3. Okay, ciliary muscle is circular with those suspensory ligaments attached to the lens in the middle. Suspensory legs attached to lens. So let me show you how it works here. When you look at the ciliary muscle in a sectional view like this, okay, not from behind, but from the sagittal view here, here's the ciliary muscle here. Normally, when cranial nerve 3 is not working, it's a parasympathetic function. I should have mentioned that. The sympathetic function is on. The sympathetic function is for distance vision. The muscle isn't contracted. Okay, so let me write that down. The sympathetic function, SYM, is for distance vision. See far. Sympathetic function is basically the ciliary muscle is not contracting, it's relaxed. During that time when the muscle is relaxed, the suspensory ligaments are actually pulling tight on the lens. Ciliary muscle relaxed. I'll say LIGS, L-I-S, pull lens. They stretch the lens. And that's what's trying to be illustrated there for distance vision. The whole goal of vision is to focus the light rays, the letter R in this example, on the back of your eyeball where your photoreceptors are. Okay, so that's to see something far away, say 20 feet away, right? At the other side of the classroom or something. Or you're outside, you know, to watch a game and you're sitting in the stands. But if something's right in front of your face for close vision, that's parasympathetic function, cranial nerve 3. Okay, not sympathetic function. The parasympathetic function is for close vision, lens combination. Ciliary muscle contracts. Because that ciliary muscle is circular, it contracts in a way that allows the ligaments to become slack. When you're arranged in a circle and you contract circularly, the whole thing kind of, I can't illustrate it with my hands. These fibers, these ligaments will become slack. That allows the lens to bulge. The ligaments become loose, slack, lens bulges. That's the accommodation. It bulges more. Why? Because if the light rays are going through it and the lens is less stretched out, something's right in front of your eyeball. It has to bend the light rays more. Okay, it bends them more so the focus isn't blurry on the back of your eyeball. So that's how it works there. Any questions on that? This is the parasympathetic function. That's the cranial nerve. Yeah. What's your question?
Yeah, I was going to say, is that when your eyes get weak and you need reading glasses?
Mm-hmm. Yeah, exactly. About the age of 40, as you age, the lens becomes less bulgy. So it's like if you're like, oh, wait a minute, to hold the book farther and farther back, that's when you need to go to the optometrist and get reading glasses. Let's see here. If you're like, I'm 40, I don't need glasses, well then you're getting extra years out of your lens. Good for you. If you're like, I'm 30, I don't need it, and just count the years. Maybe you hit 35, you need it a little early. It's okay. There's no shame you need reading glasses. Now, this is what's happening here. You got to focus. You got the lens, as well as the cornea, but mostly the lens has to bend the light rays to focus it right in the fovea. This is where you have your highest density of photoreceptors, right? So if you don't need corrective lenses growing up, it's because your eyeball is a good length. Okay. A myopic eye is, they call it nearsighted. Well, basically, anatomy-wise, eyeball too long. The light rays are crossing too early. You want to cross here, not here. So to correct that, what can correct a myopic eye is a concave lens. See what happens here? This lens in front of your eyeball will bend the light rays a little more before it gets to your actual lens, so it focuses in the right place. So let me write that down. If your eyeball's too long, that eye, it's too long. A concave diverging lens corrects it. Corrective lenses. Nearsighted. You can see near, not far. The opposite is your eyeball is too short, hyperoptic eye. You're farsighted, you can see far but not near. Okay, hyperoptic. Hyperoptic eye. It's too short. So as you can see from the illustration, the light rays they don't merge until it gets behind the eyeball. So that will be blurry too. The eyeball's too short. So if you to correct for it, if you take a convex converging lens, it'll force the light rays to converge sooner. So when it gets to the eyeball, it's at the right point, okay, the focal plane. A convex converging lens corrects this. That's the basic idea. It's all about your eyeball length. Depends where you need. Oh yeah, thank you. Or if you don't like glasses, you can get contacts, right? It's just right on your eyeball, on your cornea. If your cornea is too sensitive, maybe you just can't wear contacts. What about if you wear contacts but you need reading glasses too? They don't really have contacts that do both. I think they're getting there, but not yet. Okay. The other function, that's the ciliary muscle. That's the smooth muscle in the ciliary body. This is not that. This is the smooth muscle in the iris. The beautiful color of your eyes has smooth muscle inside. This is also cranial nerve 3 function. So let's distinguish the ciliary muscle from the smooth muscle of the iris. The cranial nerve 3 function is pupil constriction. On a bright day. Call them your biological sunglasses. Why are you constricting the pupil? It basically restricts UV light from irradiating your retina. Okay. Now, some people like to wear shades. But what do shades do? Shades won't constrict. Shades will let your pupil dilate. It's going to let more UV in. So you better be wearing shades that have UV protection. And I never believe it if it says it has UV protection. The little sticker says UV protection. You believe that? You're letting more UV light in, okay, when you wear a shade. It's kind of counterintuitive. But this really does help. The test is you take a little pen light and you flash it on the eyeball. And if you see the constriction, that's great. What if you don't see it? Why do they do that? They usually do it for trauma patients that have a head injury. Because remember, this cranial nerve emerges off the brainstem. So if this nerve isn't working, you might say, maybe the brainstem is damaged, right? There could be pressure building inside that kind of puts a kink in the nerve. You ever get a kink in your garden hose at home? The water doesn't come out. What if you get a kink in your nerve? The function doesn't work. So that's a quick test to see if that nerve is working. Attached to the brainstem. What if one side is working, the other side isn't? That's bad. You ever hear that? Oh, the pupils are fixed and dilated. Why would they be fixed and dilated? Because if parasympathetic function is damaged, cranial nerve 3, and this takes over, okay, they're fixed and dilated because that nerve is not working. For whatever reason, that can't be good. All right, I'm going to move away from cranial nerve 3. I did 4. That was trochlear nerve. 5 is the trigeminal nerve. Now, the trigeminal nerve, as the name implies, has 3 branches. Trigeminal nerve, the 3 branches are V1, V2, V3. My terms got mixed up with the lines. But anyways, here's what you got to do. The first branch, V1, the name is ophthalmic. OPH, ophthalmic. Like when you go to the ophthalmologist, this nerve is going to the eyeball. Okay, and well, basically, it's going to exit the superior orbital fissure. Okay, I should say it's going through the eye socket. Okay. That's V1. V2. The name of the branch for V2 is the maxillary nerve, the maxillary division. You could say nerve or division. It's a division of what? Cranial nerve 5. Okay. But V2, that division, is going to exit foramen rotundum. V3 is the mandibular division. That nerve is going to exit foramen ovale. Pronounced ovale, spelled ovale. here's sensory innervation to the face. And the color code shows you basically the topographical region for the innervation. This is sensory function. And these nerves exit here, but to exit in the front of the face, you got the superior orbital nerve, suborbital notch or foramen or notch right there. There's an infraorbital foramen, and there's the mental foramen there. And this is all in your skull lecture notes. I don't want to rewrite it again. But see how these nerves like go to the skin of your face? So basically this nerve helps you feel your upper face, your forehead region. I'll use blue because what is feel? It's a sensory function, right? This one feels upper face. The B2, maxillary division, helps you feel upper jaw.
Are all of these sensory?
Yeah, what I'm teaching now is all sensory, and B3 helps feel lower jaw. Sensory. Now, B3 is mixed. It has motor function as well as sensory. So let me kind of show you what that is. Helps you chew. Mastication. Let me show you some pictures first before I show you those muscles of mastication. Here's V1. Now, when you study these figures, if you have the atlas, see how it's lassoed around the trigeminal nerve? And do you see why there's the three divisions there? The nerve, if you follow, you can follow this back to the pons, but basically the brainstem, 1, 2, 3. Okay, that's what you got. Ophthalmic, a superior orbital fissure. There's V2. See right there? It's exiting foramen rotundum. You can see it going to the upper teeth, giving branches there. You can see how there's a nerve there exiting the front of the maxillary bone, the infraorbital foramen there, so you can feel your upper jaw. V3, mandibular division, shown there. And the anatomy I taught you before, V3 exits the foraminal valley to get out of the cranial base there. But then it goes down to the jaw, and it enters the mandibular foramen and is inside the jaw. Okay, and it's giving off all these alveolar nerves so you can feel your teeth. And then it exits here, the mental nerve out of the mental foramen, and basically, well, that's in your nose. Okay, I already went through that. Now I want to talk about the motor function. There's muscles here that this nerve innervates. Know these two muscles, masseter and temporalis. Innervated by V3, the motor function. Be able to basically know these muscles. Innervated by V3, closes jaw. You can refer to these as muscles of mastication, help you chew. Okay, there's a blank figure. Move on to facial. Well, because they help you chew, I reteach these muscles in 431 in the digestive unit. If you take me for 431, you'll know those again. I'm going to do facial nerve. Here's a nice picture of facial nerve, how it exits all these little branches here. These branches, you don't have to know, but you have to know facial nerve, just not all the names of these branches here. Well, you can see why it's called facial nerve. That's most of your face. As I'm going through this, maybe you're thinking, maybe I don't want to take you for 431. Well, you just make room for somebody else. That class fills really fast. Next up. it's good that when you go through your prereqs like this, you have choice. Sometimes you don't. So I'll take this instructor, not that instructor. When you get in your professional program, man, you got no choice. That's it. You take the one class with the one guy or the one girl, and that's it. So the advice is, be able to learn from anyone you take. Okay? Don't blame it all on the instructor. They're doing this, they're not doing that. I'm this kind of learner. Sometimes you just get stuck and you have to roll with it. And you'll be flexible, have a good attitude. You'll learn something. You'll pick something up. I'll say the most important training you're going to get is when you actually get your first job. Yeah. And you're actually in the clinics. Like, who's going to help you? I don't know. That's kind of scary. What if nobody helps you? If you're good, you'll be fine. Okay? But if you really need help, hopefully, man, you got a good supervisor. They teach you everything they know. You'll know immediately if they want to help you or not. And you just kind of go and fill it out. But yeah, you start accumulating that clinical experience. You start feeling like a pro. Just remember, you be a good teacher, even if the people above you weren't. Okay? Otherwise, the world isn't going to be a very good place. All right, getting back to this stuff. Look at all the stuff this nerve does. I'm going to try to narrow it down for you. It cries, it tastes, it salivates. That's all glandular stuff. Tears, tastes, and salivation. Well, okay, crying is a gland. Salivation is a gland. Taste, that's in your tongue. Taste buds, that's not glandular. It's right here. But here's everything that cranial nerve 7 does. Facial nerve. Let's do the first one, cries. Crying is a motor function. When you stimulate a gland to secrete, that's visceral motor function. Okay? Cries. So the gland, now there's 2 nerves shown here, 5 and 7. Here's 5 with its 3 divisions. There's some kind of piggybacking of nerves, and you don't have to know that, but here's 7, follow 7. If you follow it to this gland here, it innervates the lacrimal gland for tear production. The other one, the other functions include, it basically serves the anterior 2/3 taste buds of your tongue. So it tastes. Remember the fancy word for that is gustation? Anterior 2/3 tongue. Inside your tongue are the taste buds. I'll show you a picture later. So that's not motor. Taste is a special sense, right? Moving your tongue will be what? Sensory or motor? Motor. But this is taste. That's sensory. Burning your tongue, sensory. Okay? Anything taste, feel. So this is taste. I guess things don't taste hot. You can definitely burn your tongue. That's sensory. Okay, the other thing is salivation. Know the names of these 2 salivary glands, the sublingual gland and the submandibular gland. The submandibular gland, you can only see it if you dissect. This gland, if you want to see it, lift your tongue up, look in the mirror, and under your tongue you should see saliva accumulate under your tongue, because that's the ducts of this gland, the sublingual gland. So know that for salivation, 7 innervates sublingual, submandibular, salivary, I think that's those nerves. 7 does a lot. Okay, that's all I have for this picture there.
With salivation,
Yeah.
that's not a motor function.
It is. Yeah, anything that we innervate a gland, make it secrete, consider it visceral motor. So visceral motor would be crying and salivating. Okay. Taste is a special sense. You go to the restaurant, you're starving. You smell the food, that's sensory. You see the food other people are eating, that's sensory. And it makes you salivate, that's motor. Okay, well, the nerve, if you follow facial nerve, I think I skipped over a slide here. Let me go back to this one. Facial nerve exits the internal acoustic meatus. Look for that in the temporal bone, the petrous region. A lot of students have trouble identifying that one. It seems to escape you. The internal acoustic meatus, look for it on the temporal bone, petrous region. Now, there's part of that bone, it gets into this facial canal inside the temporal bone, and a branch of 7. Here's 7. Goes there. That's your inner ear chamber, the middle tympanic cavity. We'll get into that Wednesday. But this exit point right here is called the stylomastoforamen. And when it exits there, it's going to give off a lot of branches to innervate what we call the muscles of facial expression. So know this exit point. 7 exits as well. After it exits internal acoustic meatus, a branch of it will then exit stylomastoforamen. Stylomastoid foramen. Gives many branches, which you don't have to know. Just call 7 to innervate muscles of facial expression. So muscles so you can convey expression. Well, let me go through them. You have to know these. So I'm not going to list them on the board because I think the slides do a good enough job outlining it for you. So these muscles, whatever you got to do, study these slides. I won't ask you attachments. I'll ask you innervation. It's all 7 facial nerve. You should be able to identify it and know what mood it conveys. For example, occipital frontalis on the right, look at the muscle on a picture. On the left, look at when it contracts, see how it wrinkles your skin to convey you look surprised, right? Oh. So these muscles, they're not in moving joints, are they? They're inserting on your facial skin to move skin of your face to help you convey expression. Muscles of facial expression. That one conveys surprise. So the action is a move, an emotion. Orbicularis oculi, circular muscle that helps you close the eye, like when you wink. Nasalis helps you flare your nostrils, maybe when you get angry. Levator labii superioris, it elevates your upper lip, like when you snarl. Okay. There's zygomaticus major and minor. They're going to basically pull the corner of the mouth laterally, superiorly, like he's doing there, as in a growl. Okay, look at depressor anguli oris. Now on the picture, there's 2 muscles highlighted. But if it's depressor anguli oris, doing that, is it going to be this muscle or that muscle? Top or bottom? Bottom. Okay, it pulls the corners down, as in a, whatever that is, frowny face, upset. So the other one, levator anguli oris, is the one up top. as when you smile, pulls the corners of the mouth up. Buccinator. I like that one. Buccinator, also called musician's muscle. Buccinator. The musician's muscle. So when you puff your cheeks. Buccinator, buccal. What is the buccal region? Cheek. There's muscles in your cheek. And it's called the musician's muscle, like if you blow a wind instrument like saxophone, clarinet, trumpet. There's something called the embouchure. Your mouth tension to blow air through your wind instrument. It's called the buccinator. Dizzy Gillespie is a very famous jazz musician. Perhaps you've heard of him. Most trumpet players don't let their cheeks blow out. He did. And his cheeks would inflate quite a bit, like a pufferfish. That muscle helps kind of maintain the shape of your mouth if you play an instrument. Okay, puckers. That's orbicularis oris. Don't confuse it with orbicularis oculi. That's your eyeballs. This is orbicularis oris. Helps you, pucker up as when you kiss or whistle. Okay, this is mentalis. Okay, remember like the mental part of your chin, the mental foramen. Well, that muscle mentalis helps you protrude lower lip as he's doing as when pouting. So those are the muscles of facial expression you're responsible for. Study those. I'm going to move on to 8. So, muscles of facial expression. Sensory or motor function? Motor. It's muscles. Is it somatic or visceral motor? Somatic. Yeah. So what are Botox injections? It's a neurotoxin. It numbs these muscles, so if the muscles don't contract, less wrinkles. I guess you look better. That's why people do it. Okay, this nerve is the vestibulocochlear nerve. The name implies it has 2 divisions, the vestibulo and then the cochlear. Cranial nerve 8. All right, so let me show you the next slide, which illustrates the 2 parts of this nerve. The vestibular part, they all innervate different parts of the inner ear structure.
You did say this was 8, right, Professor?
Oh yeah, did I write 7? Boom. Thank you. The vestibular part is for the sensation of the balance and equilibrium. The cochlear part is for hearing. This is all special senses. Okay, this nerve is strictly sensory. There's no motor function here. Now, I'm going to give a whole lecture on hearing on Wednesday. So we're going to study the hair cell that's responsible for this. Okay, so stay tuned for the hair cell. For now, just kind of list that. This nerve exits internal acoustic meatus. Supracochlear nerve exits. All right, so I'm moving on to 9, 10, and 11, and they all exit the jugular foramen. Okay. So I'll start with 9, glossopharyngeal nerve. Just note for now, cranial nerves 9, 10, 11 exit jugular foramen. The whole jugular foramen is named for the blood vessel that exits there, the internal jugular vein, the main vein that you see in your neck, but you have to know these cranial nerves. Let's start with the glossopharyngeal nerve. It has a lot of function. Glossopharyngeal nerve, cranial nerve 9, glossopharyngeal nerve. Glosso means tongue. Pharynx means the pharynx, neck, swallowing region. Here's the functions listed there. Tastes. Taste is sensory function, and well, the facial nerve did the anterior 2/3 of the tongue. This nerve serves the posterior 1/3 of the tongue. The taste bud's there. Posterior 1/3 tongue. Taste buds. Sensory function. Salivation is a visceromotor function. It's going to innervate a nerve called the parotid salivary gland. That's a third salivary gland that you have to know. For salivation, visceromotor function. Salivates, so innervates parotid salivary gland. Picture of that gland shown on the right. Superficial nerve right there. You see it right next to the masseter muscle. There's the duct. The parotid duct, it has to pierce the buccinator muscle to get inside by your upper jaw. So the gland has a duct. So know the parotid salivary gland has a duct that pierces buccinator. Some people say they can feel it secrete kind of by their second molar in their upper jaw. I've never been able to feel that, but there is some saliva secretion there. Something I do feel, you take a first bite of food, you ever feel a tingling in this region? You're stimulating that gland, okay? Here's a picture of a taste bud. There's these little gustatory hairs deep inside your tongue, which trigger the sensation to these fibers of cranial nerve, well, whether it be 7 or 9. There's a histological picture of it. There are little points where the food gets worked in to convey the sense of taste. Now, but that's not all the sensory function for taste. We have taste for 7, 9, and also 10. So you don't use these too much. You have some taste buds in your epiglottis, but technically, if I want to be complete about the taste sensation, we must include 10. I'm going to throw that in as a little side note. It's the vagus nerve. Taste, you got taste buds in epiglottis. Have you ever had food stuck way back in your mouth when you're almost choking? You can kind of taste it a little bit. You got taste buds back there too. Okay, well, I'm going to go back. I want to finish taste. We have swallows and we have pressure chemosensor. So taste, so swallows. The nerve swallows because this nerve innervates skeletal muscles of the pharynx, pharyngeal muscles. They're called constrictor muscles. They're right here, the back of your throat. Okay. To orient you, that's your Adam's apple in men, your voice box. And the constrictor muscles are right behind it in the pharynx. Constrictor muscles of pharynx. And in 431, this comes up again when we talk about the regulation of blood pressure. There's a major artery of the neck called the carotid artery, common carotid. And right where the carotid bifurcates into the external and internal carotid arteries, there's a little sinus, a dilation, that has a pressure chemosensor. Okay? So it helps this nerve, which innervates that carotid body in the carotid sinus, helps monitor blood pressure as well as blood gases. So it's a pressure / chemosensor. So I'm just going to write how it innervates the carotid sinus. I'm just copying it right off the slide. You can lift up carotid sinus. You can lift up carotid body. Carotid. Again, carotid is one of those funny words. It's pronounced carotid, but it's spelled carotid, like ovale. Foramen ovale, spelled ovale. Kind of like one of those funny anatomy things. Okay, I'm done with 9, but the name is hard to remember. If you can remember that that's for tongue and that's for pharynx, that's part of the function, maybe that'll help you remember the name for 9, glossopharyngeal nerve. Number 10 is vagus, not to be confused with Las Vegas, right? Because that's a different spelling. But students always use that to remember, and that's okay. But don't spell it V-E-G-A-S, right? Cranial nerve 10, vagus nerve, derivation of the word vagabond, not Las Vegas. Vagabond goes everywhere, right? A vagabond, traveler, goes everywhere. This nerve goes everywhere. I mean, everywhere, like your whole body. It's a cranial nerve. It goes to the heart, chest, everything in the abdomen. I just make it simple. I say it gets viscera. You can give a whole lecture on cranial nerve 10. I'm not going to. Let me give you one thing as an example of what cranial nerve 10 can do. For example, the sympathetic function would be to speed up heart rate, but cranial nerve 10 has a parasympathetic function, which helps slow down the heart rate. Okay, let me just give you that as a function. Example of one thing. Decrease heart rate. It's a motor, it's a parasympathetic function. I gave you one other one that this nerve does. What is it? That was sensory.
Oh, for the tongue.
Yeah, taste. Does that too. But does everything. I just want to at least give you one example of what this nerve does. I want to move from 10 to 11, the spinal accessory nerve. I'll put spinal in parentheses. You can just call it accessory nerve because it has access to cervical spinal nerves. This is a cranial nerve, but it has access to cervical spinal nerves. Hence the name, has access to cervical spinal nerves. So spinal accessory is a more appropriate name. It's a cranial nerve that has access to nerve fibers from spinal nerves. Now, this picture kind of illustrates it. If you're going to have access to spinal nerves in the neck, you have to be in the neck. That's shown here. See these nerves there? It's a motor function. It's red. So this nerve, the course of it, it'll start here in cervicospinal nerves. It'll ascend. It'll enter the foramen magnum, but then exit jugulariform. Okay. First enters foramen magnum, then exits jugulariform. What we say is it helps move neck and shoulders because it innervates two muscles that you have to know, the sternocleidomastoid and trapezius. Helps move neck and shoulders. So the muscles that innervate sternocleidomastoid and trapezius. So that's motor function only. That's it. No sensory function for this nerve. And let's get to the last cranial nerve. Exits hypoglossal canal. Hypoglossal nerve exits hypoglossal canal. Cranial nerve 12.
Excuse me.
So I'm writing hypoglossal nerve exits hypoglossal canal. Look for that on the occipital bone. Basically, this nerve helps you move your tongue. There are some tongue muscles, so you can stick your tongue out, pull it back in, move it around your mouth. We won't learn the different tongue muscles, just know the function it moves tongue. But no, is that sensory or motor function? Motor, move your tongue. Strictly motor. All right, let's take a break and when we come back I'll give a lecture on the eye.